Welcome to The Explainer. Today we're going to break down how the exact same core principle can be used to build trust in two vastly different worlds, decentralized energy markets and national defense. Yeah, you heard that right. From microgrids to military strategy, it turns out they're built on the same foundation.
So let's start with a really simple question. In a super complex system where you can't possibly see everything yourself, how can you be absolutely certain that an action really took place? How do you know?
Well, the answer is a concept we're going to call a trust engine. And this idea is quietly reshaping how we build all kinds of critical infrastructure. It's all about separating the doing from the proving. Okay, let's really dive into this.
To see how this actually works in the real world, we're going to start with a pretty fascinating case study from the energy sector. There's a company called Forerunner, and they've built their entire business around this idea.
Forerunner's model is built on this really brilliant separation of duties. You've got one part of the company, the Doer, that goes out and deploys all the physical stuff. The microgrids, the data centers, they actually generate the value. Then you have the Verifier. Now this is a totally separate, read-only digital auditor. It can see everything the hardware does, but, and this is key, it can't control it. Its only job is to prove that the value was created.
Now this is where it gets really interesting. Because you've separated the doing from the verifying, you actually create a brand new tradable asset, basically from thin air, or, well, from verified data. By creating this undeniable proof, you've built something that regulators and investors and whole markets can actually trust.
And the process is totally automated. First, you gather the evidence. That's just raw telemetry data streaming from the hardware. Second, finalization. The system confirms an irreversible event happened, locking in exactly how that energy was used. And third, execution. A digital certificate, they call it an Energy Finalization Unit, or EFU, is created. And just like that, you have a perfect, trustworthy audit trail.
So the really crucial point here is that by solving the trust problem, this whole model can scale up massively. You get rid of double counting, no way to sell the same energy twice. You create a standard, turning all kinds of different energy into a single tradable asset, the EFU. And maybe the smartest part? Forerunner doesn't even run the market. They just provide the trusted foundation for other people to build on top of. It's basically the Intel Inside model for the new energy economy.
Okay, so this is a really clever model for trading green energy. But what if this whole trust engine concept applies to something with, much higher stakes? What happens when you scale this architecture from just one company to an entire nation's security?
Because this model, it's about way more than just energy. It's really about how we build certainty into systems where failure is simply not an option. So now, let's zoom way out, from a single company all the way to the level of national security, and see how this exact same architecture is being deployed.
Let's take a look at the U.S. defense technology priorities for 2026. As we go through this, you're going to start seeing those exact same architectural principles, that whole doing versus verifying thing, at play, just on a much, much grander scale.
The budget here is, well, it's immense. Over $900 billion. But the key insight isn't just the number, it's where the money is going. The focus isn't only on new weapons anymore. It's on creating systems that are more resilient, more data-driven, and, most importantly, verifiable.
Just take supply chain security. This quote from the Defense Logistics Agency, it says it all. They're using AI not just to move stuff around, but to verify the integrity of the entire supply chain. The AI is basically playing the role of that verifier, predicting risks before they even happen, but on a global scale.
And you see this verification layer being built out everywhere. You have bespoke AI platforms like GenAI.mil, the military's own generative AI. You have intelligence tools like Project Maven, which uses AI to analyze mountains of data. And you have these huge data hubs like Advana. All of these are aimed at one thing, creating faster, more reliable, and more verifiable insights from just an insane amount of data.
And this illustrates perfectly why you need trust in the hardware itself. The future of air superiority isn't about one plane. It's about multiple complex systems all working together. You've got the Air Force's next-gen fighter, the Navy's version, and these autonomous wingman drones flying right alongside them. A human pilot has to be able to trust the data coming from their autonomous wingman instantly. And that only works if you have a shared, secure, and constantly verified data architecture holding it all together.
You can even see these strategic choices playing out in real time just by following the money. The White House is clearly putting its chips on the Air Force's NGAD program. Look at the Navy's FAA-X program. That massive funding gap tells its own story about where the big investment in these future trusted platforms is really going.
So let's bring it all together. How does a decentralized energy grid possibly connect to the future of national defense? Well, the answer is all in that shared architecture.
The underlying blueprint is identical. In both systems, you have a physical action layer, the hardware, the troops. You have a verification layer driven by data and AI, and the result of that is a trusted asset. For Forerunner, that asset is a digital token. But for national defense, it's something way more critical: the verifiable readiness of an entire military force.
So if there's one thing to take away from this, it's that building trust through verification isn't just some clever business model anymore. It's becoming a core principle for designing any system that has to be secure, scalable, and resilient. Doesn't matter if it's powering your home or protecting a country.
And that leaves us with a final thought to chew on. If we can mathematically prove that something happened, beyond a shadow of a doubt, what does that do to our idea of trust? What's the role of human trust in a world of perfect verification?